Hello everyone, we are Group 5. Our project is to discover factors associated with road traffic accident using collective analysis. Traffic accident has become a social problem. It's also one of the 4 major causes of urban death. The government has also investigated and analyzed the causes of traffic accidents. Road traffic crash results from a combination of factors related to the components of system compression road, for example, the traffic lights, and the environment, the vehicles, the road user, and the way they interact. Some factors cause a collision to occur and therefore part of the cause of the collision. Other factors exacerbate the impact of the collision, which results in severe trauma. This project is aiming to analyze the road traffic accidents happened in a year in the US to discover and understand different factors that cause the accidents. The first step of our project is to find the right dataset. This is the dataset originally provided to us. After discussion, we think this dataset is not good enough. This dataset only provides time, coordinates, and vehicle types. These factors are far from enough for our analysis. We need a more comprehensive dataset. We have 2 basic requirements for datasets. First, big enough datasets and multiple factors. When there are enough kinds of factors, we can better analyze which factor has the greatest impact. According to these 2 requirements, we have found the appropriate dataset, which records more than 3 million traffic accidents in the United States from 2016 to 2019. And the dataset contains a lot of factors. The factors included are shown below. This dataset includes 49 factors, so we can analyze which factor has the most impact in a traffic accident. Some of these factors have little influence on the results, or some of them are the same in most of the data. Therefore, we will ignore these factors in the subsequent analysis to focus on the more important factors. They are visibility, weather, position, humidity, road situation, sunrise or sunset, and time. The next part is the overview of design to fulfill these aims.
System design encompassed 4 major steps. First, we decided which storage or file system to use. Next, how we are going to prepare the data for analysis. Then, the processing that will be carried out on the dataset to extract insights. And finally, using visualization tools to express those insights. The dataset contains traffic accidents information from 2016 to 2019. However, we are only going to be focusing on some key parameters in the dataset, such as the location of the accident, the weather conditions at the time of the accident, the visibility, and the time and date of the accident. With over 3 million records and a file size of over 1.2 gigabytes, the dataset matches the scope for a big data application. Based on that requirement, we decided to use HDFS since it can handle large datasets. It's much cheaper to use because it can scale performance easily using many low-performance machines, and it can be scaled easily to cater for larger datasets. For example, working on 10 years of data instead of 3 years is also possible. To prepare the data for analysis, we performed pre-processing on it. The dataset contained considerable amounts of missing and null values. For example, the precipitation parameter had many missing values. As a solution to this, we planned multiple data manipulation techniques in Spark data frames to fill in any missing values. The analytical processing was designed to be performed using Apache Spark RDDs in conjunction with HDFS. This combination allows for faster processing than Hadoop with MapReduce. This is because Spark performs computation within RAM or system memory. It also allows flexibility with manipulating data, with key operations such as map, filter, and collect. Another key feature is that Spark is able to recover from failures completely by itself, featuring high fault tolerance. RDDs are parts of a larger dataset. It is the fundamental unit of data that Spark processes. Since it works on main memory, in case of a memory loss, it can be recreated, which makes it very resilient. It also spreads the data across many memory locations, allowing for distributed computing. RDDs support two types of operations: transformations, which return new RDDs, for example, the map function, and actions, which involves I/O operations and computations such as count and first. The transformation operation is key to this project, allowing us to perform important queries and data transformations. Here you can see an example of an input RDD which has 6 data points. By applying the map function, key value pairs are generated respectively for each data point. In the final step, identical keys are reduced to perform an operation that is similar to MapReduce. The execution and outputs for the driver application are handled by the Spark context. The DAG scheduler receives an RDD from the Spark context. It then divides it into stages and then submits them as stage tasks to the cluster manager. The cluster manager then finally distributes the work across worker nodes. For visualization, the most important aspect was marking the physical location of the accidents on a geographical map. This was done using Matplotlib and Seaborn for graphs, and another library used to visualize geographical maps. Lastly, we used line and pie charts to perform multidimensional views of accident trends and various factors that cause them.
Now let's talk about implementation. The main technique is PySpark, which is a Python API for Spark. Some public classes including Spark Context, the main entry point for Spark function, and the Spark Conf for configuring Spark. The first stage is data storage. Due to the issues on the CDRC cluster, and we cannot use distributed nodes for HDFS to do Spark jobs, so we use local file system to store dataset. As for data access, we read CSV file to Spark data frame, which is a distributed collection of raw objects. The next part is data preprocessing. We use Spark Circle to select the fields we need in dataset and then filter the records where 30 is equal to 3, because what we want to do is fatal accident analysis. There are some missing values in fields: temperature, humidity, visibility, wind speed, and precipitation. For the first four, we replace the non-value with the average value in that day, and the last one, precipitation, we replaced by 0. Then we convert Spark data frame to Spark RDD to do data processing. The function we used is called calculate frequency, that calculates the number of occurrences of the same word. It is the word count. For example, in weather condition, if the input RDD is showing here, then after map, group by key, map value based on sum operation, we can get a result. that the number of cloudy days is 3 and the others are 1. The overall result for weather condition is shown here. And we put the weather condition and the number of times it happened into two lists. Then we visualize it by pie chart. As you can see, car accidents happened in cloudy days accounted for the most. Then I will give you a demo. Still using weather condition as an example. This is the function for word count. Regarding to each weather condition, there are some different descriptions, such as partly cloudy or totally cloudy. So we use are like cloudy to filter the data that contains cloudy. Then we do the calculation on clear, overcast, rain, and snow and fog. Because I run the program on my computer, it is slow, but if it can run on cluster, the speed will significantly increase due to the distributed computation. And now we wait for the result. Yeah, here it is.
When the visibility is between 10 and 20, the rate of accidents is the highest. In foggy weather, warning signs will be set up on the road and drivers are required to drive at a limited speed. When visibility is too low, drivers are restricted from entering the road. But when the visibility is 10 and 20, drivers can see the traffic conditions in the limited vision. They're likely to maintain the high-speed driving, so the accident is most likely to occur at this time. Traffic accidents are easy to happen on sunny, cloudy, and overcast days. There is a higher travel rate and larger traffic volume on good weather days. And traffic is reduced in bad weather. Correspondingly, bad weather accounts for a small proportion of the year. You can see there are more accidents in the east of the United States than in the west. The eastern part of the United States has more people than the western part, so it has more vehicles. Due to the impact of the Rocky Mountains, the traffic in the west is inconvenient, so there are few vehicles on the road, while the east is dominated by plains, with more roads, railways, and complex traffic routes, so the number of traffic accidents is large. The number of accidents with a humidity above 40 accounts for 85% of the total. When the humidity is too high, it is difficult in hot dissipation of human body. That may lead to driver's temperature rise, heartbeat, acceleration, dizziness, and other symptoms will affect driving. The glass inside the car is easy to fog, and the driver's vision is not clear that may cause car accidents.
Hi, this is Henry, and I'm going to talk about the road situation. And here we choose 8 factors as our research, and the chart of results here. According to the most commonly 95% of level of confidence in statistics, which means those factors that more than 5% are not small probability events. So, junction and traffic signal are two possible factors of road situation that will cause the traffic accident. The reason should be the driver may not be aware of a danger due to the vision and other reasons in the junction. As broken of traffic signal also will cause an accident. And next is time. So as we can see, nearly 3/4 of accidents happen during the day. The reason is that the volume of traffic in the daytime is larger than at night, so the number of accidents during the day is also more than happen in the night. Also, we can see the peak of accident here, which is mainly from July to December. It shows the incidence of traffic accidents is also seasonal, mostly in summer and autumn. As we mentioned before, the high temperature in summer and autumn easily affect the humidity. And humidity is one of the most important factors causing accidents. So more accidents happen in summer and autumn. In the last chart, we can see some hours have more accidents because morning peak and evening peak are rush hours of going to work. At this time, the traffic is large. And here we choose season, weather, and time as our collective analysis. And we found the number of accidents is the largest in the evening peak on the cloudy day, no matter which season. So be careful in this case, as it is most likely to have a traffic accident.